When we look up at the night sky, we're really only seeing a fraction of what's truly out there. For decades, scientists have puzzled over a deceptively simple question. Where is all the universe's missing matter? Not just the ordinary stars and planets we can see with telescopes, but the invisible mass that holds galaxies together, that bends light as it travels through space, that hints there's so much more out there than meets the eye. Let's start with the basics. If we added up every star, every planet, every asteroid and cloud of gas we can detect, it accounts for only about 5% of the total mass energy content of the universe. Another 25% is what physicists call dark matter, a mysterious, invisible substance that doesn't shine, doesn't absorb light, but still exerts gravity. And the final 70%? That's even stranger. Dark energy, a force that seems to push the cosmos apart faster and faster, accelerating its expansion. But here's the twist. Even within that 5% of so-called ordinary matter, the protons, neutrons, and electrons that make up everything we touch, a significant chunk is still missing. Based on what we know from the Big Bang's leftover radiation and the formation of light elements, there should be more ordinary matter drifting through space than what our telescopes actually detect. So where did it go? One clue comes from a field of study called the cosmic web. Astronomers now think much of the missing ordinary matter exists as hot diffuse gas spread between galaxies, called the warm-hot intergalactic medium, or WHIM for short. Imagine vast filaments stretching millions of light years, like spider silk spun across the universe. Too thin to see directly, but dense enough to bend light slightly, or scatter X-rays in subtle ways. In 2017, two teams of scientists working independently found persuasive evidence for this idea. They studied light from distant quasars, brilliant beacons powered by supermassive black holes, and noticed slight absorption patterns that match predictions for hot ionized gas spread between galactic clusters. This means we're not missing it entirely. It's just so faint, so diffuse, that detecting it requires the most sensitive instruments ever built. But the WHIM doesn't answer everything. Some researchers argue that even more ordinary matter might lurk in dim dwarf galaxies, in rogue planets drifting in the dark, or in vast clouds of cold gas yet to be mapped. Our cosmic inventory is still incomplete. And then comes the deeper question. What exactly is dark matter, the other major piece of the puzzle? Decades of experiments have failed to pin it down. It's not made of the usual atoms. It doesn't interact with light or our standard forces, except gravity. Some scientists bet on exotic particles like WIMPs, weakly interacting massive particles. Others suggest axions, or even primordial black holes formed right after the Big Bang. There are wild ideas too. What if gravity itself behaves differently on cosmic scales than Einstein predicted? What if the universe holds hidden dimensions that dilute the force of gravity in ways our minds struggle to picture? In some sense, the missing matter problem is as much about our imagination as it is about telescopes. Our tools are improving, our simulations are sharper than ever, but the biggest questions demand leaps of creativity. There's a philosophical twist too. Some thinkers argue that what we call missing might be a flaw in our models. Maybe the cosmos is telling us our equations are incomplete, whispering that reality is stranger than even our boldest theories. If dark matter is a ghost, then perhaps our view of the universe is like a fish in a murky pond. We can sense ripples and currents, but the true shape of the world remains hidden. Even now, billions are spent on particle detectors buried deep underground, on radio telescopes tuned to the hiss of intergalactic gas, on satellites measuring the faint afterglow of the Big Bang. Each experiment peels back a layer, but the final answers remain just out of reach. In the end, the search for missing matter is more than a scientific quest. It's a testament to human curiosity. It reminds us that despite all our progress, the cosmos still guards its secrets well. The atoms in your body were forged in ancient stars, yet the vast ocean that connects everything is still mostly invisible, waiting for us to find the right questions to ask. So, where is the universe's missing matter? Some of it floats between galaxies as hot gas. Some hides in faint structures yet to be mapped, and some might not be missing at all. It could be a signal that our understanding of reality itself is still evolving. One day, future generations may laugh at how blind we once were, piecing together cosmic puzzles with clumsy tools. Or perhaps they'll feel the same wonder, looking out into the infinite dark, asking the same timeless question: what else is out there, just beyond the reach of our eyes?